Hello and welcome everyone to today's webinar on Pulumi Insights for Multi-Cloud Deployments. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today, we're excited to dive into the search, analytics, and intelligence capabilities of Pulumi Insights and show you how each feature can make your team more productive. We'll also be recording the session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Webinar Pulumi Insights that you can access at the QR code or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there, you can search for the webinar channel. We'll also be checking the Zoom chat and the Zoom Q&A areas throughout, and we'll open up for live Q&A after the demos conclude. Today's webcast will be presented by Josh Kudroff, Senior Solutions Architect at Pulumi, and Eli Schilling, Developer Advocate for Cloud Native and DevOps Services at Oracle. So without further ado, I will hand it off first to Eli.
Excellent. Thank you, Tara, and welcome everyone. Good morning. Great to see you all. Good morning, good day. And as Tara mentioned, I'm a developer advocate here at OCI, and really excited to spend some time with all of you today talking about Pulumi and some multi-cloud deployment solutions. So without further ado, how about a little Oracle Cloud in a nutshell to get us started today? I just wanted to run through the app dev landscape here really quick. I know this is somewhat of an eye chart, but just to kind of see, OCI is really built on open standards. In addition to core infrastructure, compute, storage, networking, database, there's a whole ecosystem of tools available, whether you're Python, C#, Java, .NET developer, SRE, DevOps engineer, platform engineer, et cetera. A whole host of tools available to help simplify your life, make your job easier, and just solve the challenges that you face on a daily, weekly, and monthly basis in the organization. We're going to focus a bit today on the container native applications. So as we kind of dig into Pulumi a little bit, and I'll let Josh kind of take that here in a few, we are going to deploy a managed Kubernetes environment and spin up a quick web app just to kind of show how quick and easy that can be and how cool it is. So wanted to chat just briefly about our managed Kubernetes service. If you've not had a chance to use it, this is the Oracle Container Engine for Kubernetes. And really what we wanted to do is focus on all of the great work that's been done with the Kubernetes project with support of the Cloud Native Compute Foundation. So wanted to kind of make sure that we follow all of the open standards that will ensure reliability, consistency, extensibility across the board. And of course, it is a fully managed platform. So kind of help offload that undifferentiated heavy lifting of having to manage your Kubernetes infrastructure and providing a whole set of tools available for scaling, telemetry, management, and even provisioning, as we'll see with Pulumi here today, to help deploy and maintain your containerized application environment. Another benefit of our managed Kubernetes platform is, of course, full integration with the rest of our cloud ecosystem. So the ability to leverage external storage for persistent volumes, the ability to integrate with our CI/CD, our DevOps tools, using infrastructure as code, whether it's something like Terraform or preferably Pulumi. And of course, managing access control through our integrated access control platform, the networking infrastructure with load balancers, governance control, encryption, security management through the Key Vault. So just a whole host of tools tightly integrated and available for easy implementation within the ecosystem. If you've not had a chance to play with OCI just yet, it's pretty quick and easy to sign up. So it just included a couple shots here so you can take a look. I'm going to jump over really quick, and I just wanted to show the platform. All right, well, we're going to start here. And essentially, once we've logged in, we're going to have the landing page here, whole host of tools available to help get started. And one of my favorites, if you jump up to the right here, we've got a couple of tools available. There's the Cloud Shell and the code editor. So these are nice integrated tools that let you basically interact via the command line using the OCI command line interface. All of the integration is built in, so you don't have to add keys or any other credentials. It just leverages the credentials you use to log into your cloud account. And then we'll pull up the code editor here in just a minute to show you, and I have some more demos on that later. But just wanted to illustrate this really quick because we are going to be working a lot with the command line, as we often do. All right, zoom in for a minute here. Awesome. So if I just wanted to kind of poke at my environment, I can run availability domain list. And in this instance, we're going to see the resources in my environment. Of course, I have a whole host of commands at my disposal to basically query, create, and delete resources within my OCI tenancy. So that was just a quick intro on the CLI. As I mentioned, you can use the Cloud Shell. There is a developer image that runs on Oracle Linux 8 that Oracle builds and maintains. It has a whole host of tools, Java toolkits, it has Python, it has the CLI already installed. So you can spin up a compute resource and be up and running within a matter of minutes with all of those tools available to build your environment. There are binaries available for Mac, Linux, and Windows to install the CLI locally on your own desktop. And there's also a container image. So if you wanted to spin something up in Docker or in Kubernetes, you could have the CLI tools available for you quickly and easily. All right. So we did a quick look at the CLI. Before I move to my next phase, I'm going to pass it over to Josh to give us a quick intro to Pulumi and all the goodness that he has to share with us today.
Great, thanks so much. All right, so a little bit about what Pulumi is. Okay, what you need to know, there's 3 essential parts. Pulumi is an infrastructure as code tool. So that's point 1. Point 2 is that it allows you to define your resources in a wide range of programming languages, and that it works with a multitude of clouds. So we have a huge range of providers. I'll be showing our Azure native provider today, as well as our and EI will be showing our OCI provider, and we'll both be showing our Kubernetes providers. There are 2 components to Pulumi. There is the open source aspect of it, which includes the Pulumi CLI, the Pulumi engine, and all of our providers. They're all open source. The code's on GitHub. You can browse it freely. And so all the things we'll be showing today are going to be leveraging that open source aspect. In addition, we also have a free and commercial SaaS component that we call Pulumi Cloud. What that does is it manages your state file, which maintains the state of your resources and performs secrets management. And then it also has a number of other features, which I'll be showing later. It's also important to note that the Pulumi Cloud SaaS component is free forever for individual use. So if you are new to Pulumi and learning, there's really no reason not to use it as your backend. It is also the default choice. It will make learning Pulumi a lot easier. So as I mentioned, Pulumi provides infrastructure as code in any programming language and works with any cloud. You can see in the bottom part of the slide that we support all the major clouds, including, of course, OCI and Azure, which we'll be showing today. We have a range of languages. We have support for Java, TypeScript, JavaScript, Python, Go, C#, and we also have a YAML option. The YAML option, by the way, is for like organizations that are adopting Pulumi at scale, and maybe you have some folks who aren't comfortable using real programming languages. Maybe they come from a traditional ops background, and so that's where you would want to use the YAML option. We also have a ton of CI and CD integrations, as well as integrations for your IDE. Because Pulumi uses real programming languages, all of your tools will work as expected. Okay, so a little bit about Pulumi's program model. At the top level, we have a project. You don't generally deal that much with projects directly. Instead, they're kind of created for you when your Pulumi program is bootstrapped. Within your project, we have your Pulumi program. So we're actually going to be demoing 2 languages today, both TypeScript and Python. Your program is the main entry point. So in TypeScript, that is index.ts. In Python, that is __main__.py, which is a little bit of a mouthful. Within your Pulumi program, you are going to define resources. An example of a resource, say in Azure, would be like a resource group. That's oftentimes the first thing that you're defining in a Pulumi program that deals with Azure. Resources have inputs and outputs. An example of a resource group input might be its name. And then an example of the output is usually are going to be things like ID. So like another example of a resource is we're going to be creating an AKS cluster in the demo that I'll be doing shortly. We're going to use the kube config output of that resource as an input so that we can deploy Kubernetes manifests on top of the cluster we create. So to summarize, you're going to see this pattern repeated, and I'm going to go through a Pulumi program line by line so you can see this. But one resource's output becomes the input of another resource, and these inputs and outputs in Pulumi behave very much like promises in JavaScript. They're basically promises with like a little extra tracking information in the background. And what Pulumi is doing there is it's tracking like what resources depend on what other resources. So it knows what needs to be done in serial and what can be done in parallel. And Pulumi will maximize the parallelization so that your infrastructure spins up as quickly as possible. So that summarizes program. On the right side of the slide, we have our stacks. Every Pulumi program contains at least one stack. An example of stacks, so you might use them to partition your environments. You might have a dev stack, a QA stack, and a prod stack. And then within these stacks, you can configure different parameters. So you might want to have a, let's say, less worker nodes. Let's say you're running Kubernetes, and you want to have less worker nodes or less powerful worker nodes in your dev environment than you would have in your prod environment. So you can put configuration in your stack, consume that configuration from your Pulumi program, and then that way you can use a single Pulumi program to stamp out multiple environments. So it's a very powerful concept. A little bit about Pulumi's physical model. In the bottom left of this slide, you can see the Pulumi program. It supports a wide range of languages. Today we'll be showing both Python and TypeScript. Within your Pulumi program, you are going to declare the desired state of your resources, and the Pulumi engine will essentially perform a diff between your state file, which is Pulumi's view of your infrastructure, and then the Pulumi program, which is your desired state of the infrastructure. And Pulumi will figure out the diff between those, and it knows what the dependencies are. And so it will create, update, or delete the resources to make what exists in the cloud the way that you have declared it in your Pulumi program. The way that Pulumi interacts with cloud providers with cloud services is via Pulumi providers. Today we'll be showing off the Azure provider, and Eli will be demonstrating the OCI provider, and then we will also be showing the Kubernetes provider. Pulumi also includes an open source policy as code component. In a nutshell, when you use Pulumi's policy as code features, the resources that you create are passed to a function. You can define these policies either in TypeScript, JavaScript, or Python. And you can essentially, so you get a programmatic view of what resources are being created, and then you can analyze those rules and then say whether or not the resource fails compliance. So this is really useful for folks who are in like regulated industries, HIPAA, SOC2, PCI, those sorts of things. And the rules can be either essentially at a warning level or in an error level. So in a warning level, the user gets immediate feedback, hey, this is not compliant with our policies, but they're still allowed to deploy the infrastructure. If you set them to be mandatory, that's essentially an error, and Pulumi will error out. You can also build a policy of code, you can run those both locally and as part of your pipelines. So that's one of like the best features of the policy as code, as Pulumi's policy as code product. So developers can run these policies locally. They get immediate feedback on whether or not their infrastructure is compliant. And then those same policies can also be run as part of your pipeline to ensure that nothing is blocked, or to ensure that infrastructure that's non-compliant is blocked from actually being deployed. Also, so I would definitely encourage folks to sign up for a Pulumi account. That is a normal part of if you first install Pulumi, it will ask you to set up an account. It is definitely the easiest way to learn Pulumi. There's really no downside to using Pulumi Cloud as your back end, especially when you're learning. If you are thinking about adopting Pulumi at an organizational level, that is the time where you would want to maybe consider signing up for a free trial. It's 14 days of full access to all of our enterprise-iest enterprise features. And there is no credit card required. Some of those features, by the way, included like the ability to apply policy as code at scale, kind of across like all stacks if you want to, or all stacks matching a selector. We also have, it allows for team collaboration. It includes SSO, SCIM, stuff like that. So again, definitely recommend that if you're learning Pulumi, start with the Pulumi with the free tier. And then if you're considering adopting it at an organizational level, that's the time to sign up for a free trial. Okay, now it is demo time. And we will take it on over to Visual Studio Code. Okay, so here I have a blank directory. I have just started Visual Studio Code. And the first thing I will do is initialize my Pulumi project. And I do that using the Pulumi new command. So what this does is this now gives me a list of all the different templates that I can start with. So I can go somewhere down here. There's if you go with just TypeScript, that'll be a blank TypeScript Pulumi project boilerplated for you. But what we're going to use today is we're going to go Kubernetes, Azure, TypeScript. And this is this template is part of a newer series of templates that we've released that are like a little bit more fleshed out and a little bit more production ready than many of the older templates. So these are like a great way to learn Pulumi or to get started. So Pulumi is going to ask me for a few prompts that will go into the configuration files for my project and stack. So we're going to accept the defaults almost always. It's going to ask me to create a stack. That's fine. It'll ask me for a Kubernetes version. Go in default. This is a GUID for an AD group in my Azure setup. So that'll be a little bit different for you when you're setting this up. It asks us for some parameters to deal with the that affect the worker nodes. We're going to take the defaults there. It's going to ask us for an SSH key. I'm going to enter my public key here. And a location, a region. West US is close enough to me. Okay, and then Pulumi is going to execute essentially an npm install. So this output here should look familiar. Okay, so what did this create? Let's take a look. Okay, so first we have a node modules folder. Anyone that's used Node, this should look really familiar to you. So, not too much to see here. Let's jump down to this pulumi.yaml. So this is our project configuration file. It basically has a name, a runtime, and a description. And so that's how Pulumi knows like what language your program is in. Next, we have, so this is pulumi.dev.yaml. This is the configuration file for our dev stack. You will notice that all the stuff that's in here, these are where the answers to those prompts that I answered when I was setting this up. That's where they went. They went into pulumi.dev.yaml. So if we had multiple stacks, let's say we had a prod stack, you would very likely also see a pulumi.prod.yaml. And so when we pull configuration values from this file, Pulumi says, okay, what is the currently active stack? And then it pulls values from the appropriate file. But let's move on to index.ts. And we may see some red squigglies here. Yes, so there are some red squigglies. That's just because NPM is not yet completed pulling down the Azure native library. But that should not stop us from going through this file. Okay, So going through this file line by line, so we see an import. So the first thing we're bringing in is the Pulumi SDK. We use the Pulumi SDK for things that are not specific to any particular cloud. So in this case, we are using it to grab configuration from our stack configuration file. And I'll get to that in just a minute. And then we bring in a few namespaces from Pulumi's Azure native provider. Pulumi, so there are two types of providers in Pulumi. There are bridge providers and native providers. Here we are using the Azure native provider. And one of the really nice things about the Azure native provider is that it has same-day support for anything that Azure releases. The way the native providers work is we essentially pull down an open API spec, and then we generate the provider automatically after that. And we do that in a nightly process. Okay, so that covers lines 1 through 4. In the next group of lines, we are pulling in values from our configuration file. So, if we look at this line here, we're pulling in the number of worker nodes. By default, it will grab the number 3 from this configuration value, and we will store that in this variable. So that covers this block through about line 14. By the way, let me take a quick check. Let me make this one size larger just to make sure folks can see it okay. All right, so far so good. If folks let me know in the chat how we are doing. Are we following along okay? So the next thing we do is we're going to create our first resource. That is a resource group. You will notice that all Pulumi resources kind of follow the same pattern. In TypeScript, this is done using the new keyword. The first parameter is required and is the name identifier. This is what helps us identify our resource within the Pulumi state file. Pulumi will also, by the way, unless you specify an explicit name, will tack on a little random string to the end of every physical resource it creates. So this resource group, when it's actually created in the Azure portal, will have something that, like a name like resource group -ABC123. And the reason that Pulumi does this is so that you can deploy the same stack into this same environment, which in Azure, I guess, would be a combination of subscription and region, most likely. So in this way, Pulumi really, it's really helpful to be able to deploy the same stack in the same environment. If you don't want to do that, you can turn off auto naming, or you can explicitly set a name for any resources you want to create. So the next thing we do is we create a virtual network. Now, in this here, you can see this pattern that I mentioned before. We have the name, which is an output of the resource group, becomes the input of resource group name to the virtual network resource. So this is this pattern that I mentioned before when I was showing off the program model, that one resource's outputs become the inputs of another resource. And again, behind the scenes, Pulumi is keeping track of what depends on what, and so it knows what needs to be changed in what order. You'll also notice that if I bring up IntelliSense here, you can see that because Pulumi uses real programming languages, I get all of the autocomplete that I would expect from my IDE, and this will work no matter what IDE you're using, no matter what language you're using, because Pulumi uses real programming languages. There are no additional plugins required. Okay, so we create a virtual network. Then we create a few subnets. That's where we're going to deploy our cluster. And then we come down here and we create an AKS cluster. We set a whole bunch of configuration options because Kubernetes has a whole lot of options that you can set. And once we do that, we grab the credentials we query for the credentials, and then we turn them into a kubeconfig file. And then in these final lines, we do what is called a stack output. In TypeScript, this is done using the export keyword. So it's very idiomatic. So there's a couple reasons that you use stack outputs. They are essentially there so that you can access values from inside a Pulumi program from somewhere else. and that somewhere else is either the command line or another Pulumi program via stack, what are called Pulumi stack references. And you use these like stack references and stack outputs so that that's how you adopt that's how you kind of adopt Pulumi at scale by when you have multiple Pulumi programs. So you don't need to define all of your infrastructure in a single program. Okay, so that takes us through the program line by line. Again, if anyone has any questions, please let me know in the chat. I'm going to clear my output just to allow us to focus a little bit better here. And then if I want to deploy my my infrastructure, I can run the Pulumi up command. And up is short for update. So the first thing Pulumi will do when I run the Pulumi update command is it will give me a preview of what it intends to do. Because this is the first time I am running the program, you will see that it is going to create a stack, and then it's also going to create all of the other resources within a stack. Okay, so again, all of the resources that I mentioned earlier here are going to be created. And then we're going to create several stack outputs. We don't know what their value is yet. And that's why these are listed as output of string. So if we are ready to perform this update, we will select yes. And Pulumi will go off and do its thing. And because AKS clusters take a few minutes to provision, I'm going to fast forward about 5 minutes into the future and show you what the output looks like when it's done. Okay, so this is the same program. And you can see here that it's created. It takes about, let's see, 3 minutes, 3.5 minutes or so. And we get all of our resources here to show that they're created. It shows how long they took to create. And here are our stack outputs. We can, if we want to, we can now take, like, for example, the kube config output. I'm going to delete this one because it is old. And so I can go Pulumi stack output kube config and redirect that to kube config.yaml. And then I can set my kube config to be this file, and then I can run kubectl get pods -- all - name spaces. And when I run this, we will see. So this is like all you can see that everything that's running right now is in the kube system namespace. That's to be expected. This is all the stuff that Azure AKS is adding onto your cluster behind the scenes to make running a managed cluster easier. Okay, so let's clear the screen. And so now that we have an up and running Kubernetes cluster, let's deploy some resources onto it. So the first thing that we're going to need to do is I'm going to need to add the Kubernetes provider. So we are using the Azure native provider to manage our Azure resources. And now we're going to add in the Kubernetes provider to deploy Kubernetes resources onto the AKS cluster that we just defined. So the way you do that is npm i-@pulumi/Kubernetes. This is going to run instantaneously because I've already actually installed it in this particular environment. But on your environment, you would see this installing the Kubernetes provider. Cool. So now that the Kubernetes provider is installed, we will need to add a import statement for it, which you can see that I've already done up here. Okay, so now that we have a reference to the Kubernetes provider in our program, we are going to create an explicit Kubernetes provider. Okay, so let's just type that out. So the reason that we need to explicitly create a Kubernetes provider, and I'm not sure what is up. You can do it via VS Code. I believe in you. Okay. So we need to create an explicit provider here because we are trying to deploy resources onto an AKS cluster that we have just provisioned. And so if I didn't use an explicit provider, it would use whatever my whatever the like default setup was for Kubernetes on my machine, which obviously couldn't possibly include the Kubernetes cluster that I've just provisioned. So we'll give this a name. We'll call it Kate's provider. And then we will configure it with its options. And we will set its kube config to be the kube config that we grabbed from the AKS cluster. All right, cool. So now we have our provider. Now that we have our provider, we can start deploying. We're going to deploy the WordPress Helm chart. And I'm going to copy and paste this just because this is not that much fun to watch me hunt and peck my way through. But I will break down what we did here. Why is that a problem? Because I didn't put the S in. There we go. Okay. So this is how you deploy a Helm chart using Pulumi. Again, you give your resource a name. You can give it some options that are required. And then you'll see that here we have our two parameters to the Pulumi resource. And here we are using 3. You'll note here, so the third parameter here is are the resource options. And this is where we're going to say that this particular resource is using this explicit Kubernetes provider. Again, that's because we are deploying Kubernetes resources onto the very same cluster that we have provisioned. And this kind of demonstrates like the real power of Pulumi. It's that you can use this single tool to manage like all of your cloud resources. So like you can spin up whatever resources in whatever cloud you need, and then deploy your cluster, and then deploy and configure that cluster all using the same tool, potentially all in the same program. Some of the other options for resources, you can specify explicit dependencies so that you can control the order in which things are provisioned. You can say, hey, I don't ever want Pulumi to delete this resource. So you might use that for like a production database. You can set that retain on delete flag to true. So there's a lot of stuff in the resource options. And again, every resource includes the resource options. So now that we have our WordPress chart defined, we are going to grab the front end, the IP address from the load balancer that will be created. Okay, and then we're going to take that IP, and again, we're going to use that as a stack output, and that's how we're going to demonstrate that WordPress is indeed up and running. So just like before, I can run the Pulumi up command. And it's going to do its thing. It's going to calculate a diff between the state file and what we have declared in our program. And when this completes, you will see that it is going to create the Kubernetes provider and the Kubernetes Helm chart. But you'll notice that it is not going to attempt to recreate the cluster or any of the network stuff. So this is how Pulumi works. It's a declarative model. You don't have to tell it what to do. You just have to say what your desired end state is, and Pulumi will figure out the steps to make that happen. So it's asking if we want to perform this update, and if this looks good, we say yes. And this is going to take a few minutes, I think, to run, because it does create a MariaDB in the background. And I think that stateful set does take a minute to run. So while I was running, maybe we could take a look at Pulumi Cloud, because you'll notice here that we see this link here to view in the browser. And if we follow it, it will take us here. So this is Pulumi Cloud. This is the default backend for Pulumi programs. And let's go on a little brief tour of this. So this is the dashboard. You can see that you get a few widgets in here. You can see what stacks have changed recently. You can see your resource count over time. If you have an organization, you can see the members that are involved. But let's click into this stack here. So within each stack, we get an overview. You can see the stack outputs here. You can see that we are running an update right now. That's us deploying the WordPress Helm chart in the background. And you can also see an activity log. So this will give you a complete list, essentially, of who changed what and when. In production scenarios, you would also see some contextual Git info. So like you would be able to see like, hey, what Git repo is this from? What Git commit is this resulting from? Within this list of this history list, you can also see what resources were removed, updated, unchanged, or were added. And I should definitely make this bigger. Sorry about that, folks. Much bigger. So within any individual update, you'll see here, hey, you get the same output from the command line that is available in the Pulumi Cloud UI. You can also jump over to this resources tab to see all of the resources, in your stack. Many of those resources, by the way, have very convenient links that will let you jump to view them in the Azure portal. Okay, so I think our stack update has completed. Let me switch back to VS Code. Yes, it has. Okay, cool. So now we're going to grab the value of Pulumi stack output, front end IP. I'm going to put that into my paste board. And I probably typed that wrong. Yeah, it's a lowercase p. So, okay, so I'm going to grab that. And we can head on over to back to our web browser here. And we can paste that URL into here. And lo and behold, we have ourselves a running WordPress instance. Eli's mind is blown. All right. So with that, I am now going to hand it back off to Eli, who's going to show you how to do some of the stuff in OCI.
Awesome. Thanks, Josh. Quick question before we jump back over in the Q&A. The question is about whether it makes sense to use Pulumi predominantly in a multi-cloud environment. So I was going to give a quick answer, and then Josh, if you want to chime in, I think one of the key benefits of Pulumi, obviously its infrastructure is code, so it enables us to simplify the declaration of our resources, which makes it easy to sort of codify and track and manage what's happening in our environments. So whether you're using it for one cloud or multiple clouds, it does simplify and accelerate the process of deploying and managing infrastructure. In a multi-cloud environment, I think the key benefit here is, as Josh sort of alluded to early on, I can define the credentials for one or more clouds in my project and then declare all of the resources for all of the clouds I'm using in a single project or a single stack, and then apply that consistently across the board. So if I wanted to set up a multi-cloud, deploy multiple Kubernetes clusters across Azure and OCI at the same time, I could define them in a single stack. I could essentially pull in that the Kubernetes provider, or define the provider for each Kubernetes environment, grab the credentials and deploy WordPress across both clouds, and then go on to set up something like a global load balancer or traffic management to be able to redirect between both clouds in that particular instance. So there's fantastic benefit whether you're using one cloud or many clouds, but I think as you add additional clouds to your environment, it helps to simplify and streamline that process. And the one thing I was going to show too, and sorry, Josh, I'll let you get to it.
Just to piggyback on that a little bit. So Pulumi does have providers, of course, for like all the major clouds, but it's not just cloud infrastructure that you can manage with Pulumi. Pulumi also supports a wide range of SaaS providers, and so like virtually any company anywhere realistically is going to be using multiple things that Pulumi supports. So we also have providers in addition to like OCI and Azure. We also have providers for like GitHub, GitLab, Datadog, New Relic. These are all things that you can control with Pulumi. I'm going to paste in the chat a link to the Pulumi registry. The Pulumi registry has the complete list of providers that we support. And by the way, we internally, even at Pulumi, we use Pulumi to manage, for example, our GitHub permissions. It makes that way, way easier. It makes it much more auditable. Declaring these things as code. Honestly, the more things that you declare as code, generally speaking, the better. So I think that you'll find that using infrastructure as code, it's not just for cloud resources, it's also for like a lot of those SaaS resources that organizations are definitely using.
Fantastic. And there was a question in chat earlier about using Pulumi for on-prem. So I did make a note, there is a vSphere provider for Pulumi. So if you're running VMware on-prem, you could absolutely use Pulumi. Are there any other tools you might think of, Josh, for on-prem?
So the Kubernetes, if you're like running Kubernetes
well.
providers on your own metal, the Kubernetes provider does not care where you're running it. You give it a Q config, and it will, as long as that is using the Kubernetes API, you will be able to manage those resources. But yes, there is a vSphere provider as well.
Excellent. All right, I'm going to share my screen. That was a tough act to follow, Josh. So let's hope I can do this justice here. All right. Let me just advance one slide here. Josh already kind of covered all this fun stuff, but again, the benefit here is if you're already writing in Java, Python, et cetera, you don't have to learn a new language. It's just a matter of sort of adapting your existing experience to how do I define the resources and how do I utilize the capabilities in the Pulumi tool. So without further ado, I'm going to take a slightly different approach. As Josh mentioned earlier, we are going to do Python on my side. So hopefully, let me zoom in just a little bit more. There we go. All right, so we're starting from scratch here. I am just going to initialize my environment, and I'm going to be running this locally on my server rather than using the cloud backend. So you'll see here, I'm going to log into a local state file just to get that process started. And we're going to go ahead and just create the project. So we're going to create a new project in Python. Give it a project name. This is my Pulumi Pi, and the Oracle Container Engine for Kubernetes, OKE. Project description, OKE on OCI with, okay, Pulumi. This is going to be dev. All right. Passphrase, don't forget your passphrase, folks. All right, we can create the virtual environment, set up the core resources, get everything up and running here. And voila. So you'll see, if we take a look at what we have in the directory now, that created my main.python file, my state file, and then my stack configuration file as well. So I'm going to go ahead and also jump into, oops, didn't mean to copy that. We're just going to activate our environment here. Let's use virtual environments working with Python. And just do a quick install of the OCI provider for Pulumi. Give that just a moment. All right. Now, if we take a look at the main Python file right now, this is literally just importing Pulumi, and it's not doing anything. But to get started, we're just going to run Pulumi up. It's going to create or run the project file. Do you want to run this update? It's just going to create the stack with no resources, and we are off and running. Let's go ahead and edit. I'm going to add my code here. Let's see, we're going to import. And I'm not going to type the rest of this. I'm just going to grab my OKE config here. And we'll drop that in. I won't bore you with my abhorrent typing. All right, so I went ahead and actually created a virtual cloud network and a couple of subnets earlier just to simplify and speed up the process here a little bit. And in doing so, I did have to define a couple of variables. So what compartment are we using in OCI? Which subnet are we using for the load balancer, the worker nodes, and the Kubernetes API endpoint, and then my virtual cloud network as well. we're going to use Kubernetes 126.2, and then we basically define some cluster option arguments. So pod CIDR, service CIDR, and load balancer subnet IDs, along with our base cluster config. So again, just defining the compartment we're using. We're going to give this a name of first Pulumi, pi OKE, pull in our cluster arguments here from above. We're going to make this a public API endpoint for the Kubernetes API, and then just reference the variables we created earlier. And the export, we're going to just export the OKE cluster ID. So we'll go ahead and save that. And just a quick Pulumi up. And again, it's going to show us, here's what we're going to do. We're going to create this one resource. Of course, the stack itself, the existing resource doesn't get changed. So we'll hit yes. And this is going to take a few minutes to run. So while that's running, I just wanted to show one quick thing. Okay, so I'm going to get back to Cloud Shell here. Zoom in a little bit. Oops, come on. I don't know why. Oh, all right, delayed reaction. So kind of similar to what Josh did on the deployment side, but rather than do it in Pulumi, I'm just going to do it manually here to kind of illustrate the process. I'm going to use Helm to install the same WordPress application on Kubernetes. This is a cluster I deployed earlier today. And it's going to take just a minute. And here we go. So if we run take a look. Again, it's creating a MariaDB pod along with a WordPress pod. So this does take about 50 to 60 seconds. It's got to spin up that database. Once that's done, we'll have an IP address we can test, and we can poke around our WordPress environment. And you'll see here, we're also storing some information. It's going to generate a secret in Kubernetes. And so we're going to pull that WordPress password out of the Kubernetes secret store once the deployment process here is finished. So countdown, cue the Jeopardy music. Any questions while we are running through that?
Yes, please do ask anything that is on your mind in the chat. We would be happy to answer. Or even just let us know what your weekend plans are.
Look, it's Thursday already. All right, I guess I should have had 3 environments. So one to show, one to illustrate part 2, and one to illustrate the completion process here. We're getting close, I promise.
And Eli, if you'd like me to show the Pulumi Insights feature as well, I can do that now.
Give me just one more minute while this runs.
Sure thing.
So one other thing that I had done, I wanted to share while that's running, actually. Because we are working with code, I do very much like to and highly recommend making sure this all gets into a code repository. So I actually, for this case, chose to use our DevOps code repository. It's a service that OCI provides. Of course, GitHub, Bitbucket, any number of source control tools out there, definitely available for use. So what I can actually do is go ahead and clone this repository. But what I'm going to do is use the code editor inside of OCI. So I'm going to go here and clone this repository URL. I'm just going to drop it into my Git folder here. Got some other repos hanging out. And it's going to ask me for a username. I can, of course, store this stuff. But I do have to provide my credentials the first time. And my auth token. Boom. All right. Add that to my existing workspace. It's going to clone. Pretty sure the repository is empty. But what I would then do is once I finish testing my change, and take just a few more minutes here. Once I confirm this code is good, I would go ahead and initialize this directory, link to that GitHub repo or that code repo. I would go ahead and push my code. Then I can get away from trying to edit everything in Vim. I could use this very similar looking tool that acts and feels a lot like VS Code. And then I can store and manage all of my code on this side. So I think we're done here. All right, Josh, 71 seconds. Let's blame this on the internet today. I'm going to pass it back to you. Let this finish up, and then I'll take one more minute at the end just to close this out.
No worries.
So take us down the road of Pulumi Insights.
Yes. So we recently at Pulumi released a trio of features called Pulumi Insights. It comprises three things. First, there is search. That will allow you to search through all of your resources in Pulumi Cloud. We have had a lot of success with customers using this. It's like super helpful. Second, analytics, so you can take a CSV file of all of your Pulumi resources. You can plug that into your BI tool of choice and enrich that data with, for example, pricing, or like cost attribution, really whatever you want to do with it. So you can get all of your data out of Pulumi Cloud and into tools like Snowflake or your Oracle data warehouse. And then third, we have a new feature called Pulumi AI that is available on the website, and I'm going to demo those right now. All right, so I'm going to get out of slideshow mode, and I'm going to head over to Pulumi Cloud. Okay, so if you go to the resources tab, you can see here that this is Pulumi search. So if I want to look for Kubernetes, it will show me all of my resources relating to Kubernetes. All right, cool. So in addition to that, we can also filter like by type. You can see that I have run the WordPress Helm chart a few times. So we have all these like filters here that are super useful. And then here we can pull down all of this as a CSV. And then from there, if we want to bring that into a data warehouse, we can enrich that data as we see fit. So that is search and analytics. But the real crowd pleaser is Pulumi AI. So Pulumi AI, this is totally free. You can find this on the website at pulumi.com/AI. As you can see, I'll make this larger. And using Pulumi AI, you can get an excellent starting point, really, for any Pulumi program that you want to write. So if I say, show me how to run Kates on OCI, you'll also notice here that there is a language selector. I'm going to go with TypeScript. And then we can tell it to generate the program. It's going to do a little processing internally. And then it's going to start to answer my question. So, Pulumi has over 130 integrations with different cloud and SaaS providers. Within those cloud and SaaS providers, sometimes there's over 1,000 resources. I believe that OCI is like kind of approaching that number. It's definitely on the higher end. And then within each of those resources, there's like maybe 30 configuration options, sometimes more. So that's a lot of surface area to cover. And obviously, we're not going to be able to provide an example for every use case under the sun. And so that's really where Pulumi AI kind of starts to shine. So you can, Pulumi, the way to like really use this is to kind of use it as a starting point. This time, even you can use it as a starting point. And then like you paste it into your editor of choice. And then if something is not right, if you're getting red squigglies or something like that, you can give that feedback back into Pulumi AI, and it will revise the program for you per your instructions. So you can see here that that the actual generated program did not include OCI resources, which is exactly the feedback I'm going to be giving Pulumi AI at this point. So for those of you that have not used large language models yet, that's kind of the latest generation of AI technologies. They are non-deterministic, so you may get a different response with different prompts. And so that's kind of part and parcel of how these systems work. The code is not going to be foolproof. I would certainly not recommend taking whatever Pulumi AI tells you and then deploying it into your production environment. You wouldn't do that with there needs to be a review process, but where it really helps is like in just getting started, getting a really good starting point. And Pulumi AI, anecdotally, I would say gets you about 80% there. And then so I can say include the OCI K8s cluster, include, let's say, creating in this program. And then hopefully it will do just that. Thank you very much, Pulumi AI. So it is very polite in that it is apologizing for its omission. And lo and behold, the demo gods have shined, we are in their favor. And it will now rewrite the same program, including the OCI Kubernetes. Okay, it's going to create a network. But as you can see here, it is now adding in those OCI resources as we requested. And so this is kind of the pattern that you're going to be when you use Pulumi AI that you're going to see. It's going to give you some output, you're going to give it some feedback, and it's going to refine that output, and that's going to give you an excellent start for your Pulumi program. All right, so Eli, how are we doing?
Just going to run the last piece. Awesome. All right. So the last time around, we did just create the cluster itself, and that was by design. You'll notice the number of node pools is 0. So I could obviously go in here, add a node pool. I'm showing this just for one very specific component, and that is the shape. So when I pick the shape of my instance, I have a whole number of options here. This is going to be based on what I have available to me in my account. But you'll notice we have bare metal. So I could actually run a node pool in Kubernetes with bare metal compute instances. I can run GPU. I can run HPC. So these are cluster networked compute resources. That's going to give me super high throughput between my cluster nodes. If I'm running high performance compute or AI ML workloads in my my Kubernetes environment, all the way down to virtual machines that specify things like local dense SSD storage or NVMe storage, GPU, VMs. But my favorite is the Flex. So if you've not used OCI before, this is one of the coolest features in my opinion. All I do is go in here and say, you know what, I want, per instance, 32 OCPU, well, 32, and give me a full terabyte of RAM per worker node. And that is going to provision however many nodes I specify down here at the bottom. And each node is going to be 32 OCPUs and a terabyte of RAM in my cluster. So that is pretty sweet. I don't have to worry about memorizing a whole bunch of different shape types or anything. Just pick a flex and define what you need. So with that, I am going to grab the rest of my code here. Go down to the end. And just drop this in real quick. All right, so you can see here, I'm using the flex shape. And up above in my code, I went ahead and just created some variables to define number of worker nodes, default memory, and default number of OCPUs. We'll just use one processor, 16 gig of RAM, and we're going to create 3 compute resources. And again, just very basic, define the variables, consume them in the resource definitions. And at the end, we're going to spit out the cluster OCID and the node pool details itself in the export. So I'll just go ahead and save that. Again, Pulumi up. And we'll see here quickly, it's going to go ahead and not change the cluster, but it is going to create one new resource. That is my cluster node pool. I'll say yes. Let that run. And if I pop back over here, there we go. It's creating my node pool, and this will take just a couple of minutes here to spin up.
Very cool. Very cool.
All right. Well, I know Tara's got a few closing words for us, but I just wanted to share with the group here today. If you haven't yet had a chance to play with Pulumi, give it a shot, whether you're using your preferred cloud provider or OCI. Also, if you haven't played with OCI yet, come check it out. Do have some cool sign-up offers, and it's pretty intuitive, pretty easy to use. And if you want to get started with Pulumi on OCI, there's some examples and some getting started tutorials out there on the website. You can also follow or join us on Slack. We've got a public channel that Tara will share a link for. And we've got a Pulumi channel out there. You can jump in and ask us questions. And we're here to help get started. So Tara, let me pass it back to you.
Great, thank you.
Also, the Pulumi also has a Slack, and you can see that link in this slide. I can't recommend the Pulumi Slack highly enough as like a way to get familiar with Pulumi. There are tons of Pulumi employees in there, including myself, along with a very engaged community. And folks are really, really friendly and can answer any type of question that you might have, from like very, very basic things to like advanced usage scenarios. So definitely join the Pulumi community Slack.
And we do have a quick survey that'll pop up as you exit the Zoom. We'd love to hear your feedback on what we've discussed today and what you'd like to see from us going forward. So with that, should we launch some polls?
Let's do some polls.
All right.
Excellent participation from the audience, by the way. Thanks for hanging with us, folks. We appreciate it.
Thanks, everybody.
So long,
Thanks,
everybody.
Josh. Thanks, Tara.
Thanks so much for having me, Oracle. So long.
You bet.